Lesson 12.6, Permutations and Combinations. Okay, in this video, you will learn to use permutations as well as combinations. So your vocabulary, it's permutation, factorial, and combination. Okay, the first word we want to understand in order to be able to use permutations and combinations is factorial. We need to know what a factorial is. So a factorial is this symbol represented by an exclamation point. And what it means is it takes whatever numbers before the factorial. So say I have 5 factorial. 5 factorial is being the same thing as 5 times each of the integers less than it, up to 1, and then I stop. So 5 times 4 times 3 times 2 times 1. If I had factorial 12, that's going to be 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 and times 1. It always stops at 1. That is what a factorial is. Okay? Now, if I had something like 0 factorial, there are no whole numbers below 0. 0 factorial is always equal to 1. That's just a fact that you have to remember or memorize. So 0 factorial is equal to 1. Okay? So, now that we know that, we want to be able to use, to find permutations, basically using factorials. So if we have Shaquille, he has a 4-digit passcode to access his email account. The code is made up of the even digits 2, 4, 6, 8. Each digit can be used only once. How many different passcodes could Shaquille have? Okay, so we have 4 numbers that he has for a passcode, right? And he has 2, 4, 6, and 8. Okay, now we first think of what could be in this first spot. How many options are there possibly that could be in this first location? Well, 4, because there's 4 numbers there. Now, when I go to my next number, I only have 3 numbers left. Say I already picked one, that means that there's only 3 numbers left. So now there's 3 options for the second position, which means that there's only 2 options now for this last one, which means the last number, there's only 1 option for it, the only one that's left. So that means that when I multiply these together, that's going to give me the total number of passcodes you can make out of 2, 4, 6, and 8. So 4 times 3 is 12, times 2 is 24, times 1 is still 24. So there's 24 different passcodes that Shaquille can have. Okay, now this, remember, is the same thing as 4 factorial. So we could use factorials to solve these things. Okay, so you guys determine this one. Okay, now what happens if you're choosing for more numbers than what you're going to use? So in this case, when we did this one here, we only had 4 numbers to choose from for our 4-digit code. But let's say I had numbers between 0 and 9, and I only wanted to choose 4 of them, right? So in that case, that's when we're going to use something like this formula, where R is how many numbers we're going to choose. Okay, how many chosen? And N is how many available. Okay, so, and then the important thing to remember is in a permutation, the order in which numbers are organized matters. So if you're thinking about a code, right, a code is important in a certain order, or a password, right? So we want to use the permutation formula. The word processing program requires a user to enter a 5-digit registration code made up of the digits 1, 2, 3, 4, 5, 6, and 7. No digit can be used more than once. How many different registration codes are available? Now, we could do this the same way we did before, right? If we're doing a 5-digit code, right, and we're choosing out of 5, we're going to say, okay, there's 7 for the first option. Now 1 is used, so now there's only 6. Now 2 are used, now there's only 5. And then 3, now there's 4. And then there's only 3 options. Then we only have 5 passcodes, so we just multiply those. However, this could get complicated and confusing. So we have a formula. So remember, it's P, and choose R, is equal to n factorial over n minus r factorial. So remember, n is how many possible numbers we have to choose from. So in our case here, we have 1, 2, 3, 4, 5, 6, 7. We're choosing from 7 numbers. So we're saying our n is 7. But how many we're choosing is our r. So in this case, we only have a 5-digit registration code, so r is going to be 5. So we can solve this by putting this into this formula. So we're going to do 7 factorial over 7 minus 5 factorial. So now 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. And 7 minus 5 is 2, so this means it's 2 factorial on the bottom, which is 2 times 1. Now, I can cancel these out because they're on top and bottom with multiplication, which means I get that same thing that I did over here. But the good thing about this code is that you can do this on a calculator. There's a button where you could just put in your n and an r and say you want a permutation from it. You don't have to do these calculations, which is extremely helpful when we have really big n's and r's. Okay, so you guys do this one. Okay, the next thing we're going to look at is a combination formula. The combination formula is when the order doesn't matter. So, like the other day when we were picking the little cubes out of the cup, those were showing a combination. It didn't matter which order you picked them in, you still got a blue and a green or a red and a yellow, whatever it was, okay? So in those cases where the order doesn't matter, we use a combination. Now, this is the formula for a combination. N factorial over n minus r factorial times r factorial, where n is still how many you have to choose from and r is still how many you choose, okay? So if we want to use this formula again, a group of 4 seniors, 5 juniors, 7 sophomores have volunteered to be on a fundraising committee. Mr. Davidson needs to choose 12 students out of the group. How many ways can the 12 students be chosen, right? So he wants to choose 12, right? So we know that that's our R. We want to know what our N is. How many total students does he have to choose from? He has 4 seniors, 5 juniors, and 7 sophomores, which is a total of 16. So that means our n is 16. So we're using our formula, n factorial over n minus r factorial times r factorial. And that's, we're saying this is the same thing as a combination where we have 16 to choose from and we're choosing 12. So this is going to be 16 factorial over 16 minus 12 factorial times 12 factorial. So we want to be able to put this in. On your calculator, you should be able to find where the exclamation point is somewhere on there. If you can't find it, then you'll just have to do it all by hand, and I'll show you where it is in class tomorrow. But so if I put this into my calculator, I'm going to get 1,820. So that's how many different ways he can choose out of those 16 students, just 12 of them. Okay. So you guys try this one using a combination. Okay. The next thing we want to look at is determining whether we should be using the permutation formula or the combination formula. So in order to do this, we need to be able to identify whether the order is important or not. Remember, order is important in a permutation, whereas it's not important in a combination. So let's look at this example here. During a fire drill, a teacher checks the students in her row to see if everyone is present. Now, she just wants to know if her students are present. Does it matter what order they're standing in? No. So in this case here, this is going to be a combination, because whatever order those students are in, they're all there. She just wants to make sure all of her students are there. It doesn't matter if Tom is first and then Billy is last or whatever order they're in, just as long as they're all there. Okay, this one here. In preparing for a competition, a tennis coach lists his players in order of ability. In this case, does the order matter? Yes, because he wants to put them according to their skill. He wants to put them in an order. You can't have somebody that's really good at serving before or after somebody that can't serve for the life of them, so they can't win a game, right? He wants to see them in order based off of their skills. Okay, so this one is going to be a permutation because the order matters. You guys determine permutation or combination for this one. Okay. So now we want to be able to find a probability based off of a permutation or combination. So 16 people signed up for a table tennis tournament. If players are put into groups of 4 and the draw is determined randomly, what is the probability that Heather, Aaron, Michelle, and Patrick are put into the same group? So the first step we always want to do is determine permutation or combination. So in this case, does the order matter? If we have Heather, Aaron, and Michelle, and Patrick in a group, does it matter which order they arrived at the group or that they're just all together? It just matters that they're together. It doesn't have to be in a certain order. So in this case, it's going to be a combination, which means I want to use the formula C and choose R. So how many do I have to choose from? We have 16 people, and I want to know specifically that those groups of 4. Okay, so now I want to determine the number of combinations you can have where you make groups of 4 from 16 people. So in this case, I'm going to fill in my into my formula. So my formula again is n factorial over n minus r factorial times r factorial. So this is going to be 16 factorial over 16 minus 4 is 12 factorial, and then r is 4 factorial. So if I put that into my calculator, I'm going to get 1820 again. So now in this case, there are 118 different combinations of making groups of 4. So specifically, if I want to get this group, that's one possible way out of 1820. So that's going to be my probability. So 1 out of all of those combinations, 1 out of 1820 is a very small number. So in this case here, this is, oh, hang on. I lied. This one's not 1. Okay, because you can have this group be one way, but then you can have the other 3 groups changing, right? So there could be more options for this. So the way we determine that is with another combination in the numerator. So this is good for the denominator, but we want to adjust the numerator and not have 1. Okay, guys, don't hate me, but I lied again. It is the 1. So it is 1 out of 1820. I'm so sorry if that was confusing. So basically what you want to do is find the number of combinations, and specifically for this one combination, there's 1 out of all of those different combinations. Okay? So you guys determine this one, the probability for this. And that's the end of lesson 12.